All right, so in this video, we are going to go through how to find Pearson's product moment correlation coefficient, or our R value, using our graphing calculator. So here we're given a data set with an independent and a dependent variable. So our independent variable is X and our dependent variable is Y. So just to put this in context a little bit, what we're saying is that the Y variable depends on X. If we're thinking about a real world example, I'm going to choose a very arbitrary one. Let's say X is the number of rooms in your house. And we'll say that Y is the number of chairs you own. So I'm guessing, based on my worldview and the experience that I've had, that the more rooms you have in your house, probably the more chairs you're going to have. Maybe that's not true. Our R value is going to tell us something about the relationship between the number of rooms and the number of chairs. I'm hypothesizing that that relationship is going to be positive. That as you have more rooms in your home, you're going to have more chairs in your home. So I think that as X increases, Y will also increase. I don't know how strong that correlation is going to be. There's probably lots of people who have small homes and lots of furniture, and maybe lots of people who have large homes and not very much furniture. So I don't think that's going to be a very strong relationship, but I do think there will be some kind of positive correlation. Let's take a look and see. The first thing this is asking us to do is to draw a scatter plot for the data. So let's go ahead and draw a scatter plot. We can do this easily by hand. We know that we're looking at coordinate points here. So our first coordinate point would be 3, 5. We know how to put that on a Cartesian plane with an X and Y axis. However, we can do this with our calculator just to make sure that we are working with these variables correctly. So let's learn how to do it on our calculator, and then we'll draw a quick sketch by hand. So open your calculator. And remember, mine's going to look a little different than yours, but most of the functions are the same. So we're going to go to Stat, and then Edit. That's going to let us input some data into these two lists. So we have list 1, L1, and list 2, L2. We want to put all of our X values in L1. So we have 3, 6, 2, 5, and 1. In L2, we're going to put all of our corresponding Y values. We've got 5, 15, 4, 9, and 3. As you can see, we've kept all the coordinate points together. So our original coordinate point was 3 in the X direction, 5 in the Y direction. Here we've got 3 matched up with 5. And just harkening back to our contextual problem, what that means is that if your house has 3 rooms, you have 5 chairs in it. So we're going to go and we're going to generate a scatter plot here. We'd like to go to second function and then Y equals. And as you can see, the little blue writing up there says plot. So second function Y equals, and we're looking at plot 1. We are going to turn plot 1 on. So we want to highlight on and press enter. Doesn't really matter which color you choose. And in fact, if you have an older calculator, you can't choose the color. Totally fine. Not going to make a difference. We do care about the type of plot. So you can see there are several options here. We've got what looks like a line graph. We've got a histogram. We have a box and whisker plot that we're going to talk about. Or you already have talked about that, actually. But what we're interested in is a scatter plot. And that's our first option. So we're going to highlight that scatter plot. If we keep going down, you can see X list and Y list. We inputted our X values into L1. So our X list is going to be L1 and our Y list is going to be L2. That's really all we need here in order for our calculator to generate a scatter plot for us. So if we go over to graph, you can see, oops, sorry, I'm just going to delete that. There we go. You can see some of our data points here. Do you see them? These little blue squares up in the right-hand corner. However, we can't see them all. And we know that there should be 5 of them based on our data that we inputted. Why can't we see them all? Because of our window. So we need to adjust our window here in order to capture all of our data points. So we're going to go to Window, and we want to make sure that our Xmin and Ymin are set so that we can see all of our data points. So if we look back at our data set, our smallest value of X is 1. So there's our minimum. And our largest value of X is 6. So there's our maximum. I personally like to see a little bit outside of my min and maximum, just to make sure I'm not missing anything and nothing gets kind of lost on the fringes there. So I'm going to go back to my calculator, and I'm going to make my X min, rather than make it 1, I'm going to make it 0. And I'm going to make my X max, rather than make it 6, I'm going to make it 7, just to make sure I can see everything. So let's head back here and decide what we should have for our max and min in our Y direction. So our minimum Y value is 3, and our maximum Y value is 15. So again, I like to see everything. I also usually prefer to have 0, 0 involved if my values are close to 0. So I like to be able to see the origin, in other words. So I'm going to make my Y min 0. And my maximum Y value is 15, so I'm going to make my Y max 16. Now when I go to graph, it's showing me all 5 of my data points in lots of clear detail. So I can see each of those 5 data points there on my graphing calculator. This question is asking us to draw a scatter diagram. So we're going to draw a quick sketch of what we see here. So we have our y-axis and our x-axis, which we are going to label. There's y and there's x. And we need to put each of our coordinate points on here. So just like we had in on our calculator, we're going to set our x min, x max, and y min and y max. We're setting our own window here. So our x max we decided was going to be 7. And our y max we decided was going to be 16. So we can divide those up in between 0 and 7. We've got 1, 2, 3, 4, 5, 6. And do a very good job there. Hold on. 1, 2, 3, 4, 5, and 6. Not great, but we'll take it. And then we're going from 0 to 16. So we've got, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Wow, that was actually pretty impressive. Woohoo. All right, so we're going to put our coordinate points on here. The first one we have is 3, 5. So 3 on our x-axis and 5 on our y-axis puts us right about there. After that, we have 6, 15. So 6 on our x-axis, 15 on our y-axis, right about there. We've got 2, 4. 2 on our x-axis, 4 on our y-axis. We've got 5, 9. 5 on our x-axis, 9 is right about there. And then finally, we have 1, 3. There we go. So what are we seeing here? It looks like kind of linear. It actually looks kind of exponential, which we haven't talked about yet, but we will. It looks like there's some kind of pattern here in that smaller values of x are associated with smaller values of y, and larger values of x are associated with larger values of y. And this looks similar to what we were seeing here in our calculator. So moving on, we now need to find our R value. And our R value is going to tell us for sure whether we're seeing a positive or negative association or correlation here and the strength of it. So in order to calculate our R value, we're going back to our calculator. We already have everything entered in L1 and L2, so that part is done. We don't have to worry about that. We're instead going to go to Stat and Calc. So now we're going to ask our calculator to do some calculations based on the data that we've inputted. And we're actually going to be calculating a linear regression, which we'll talk about in a whole lot more detail coming up. Right now, we really only care about the regression coefficient, but we will talk about the linear regression, in other words, the line of best fit, in lots of details moving forward. So we're going to choose option 4, linreg, linear regression, AX plus B. And students who have been at this for a while will recognize right away that AX plus B is the equation of a straight line, a linear regression. We're finding the straight line of best fit. So we're going to press enter here. We want our X list to be L1 because that's where we put our X values. Our Y list to be L2 because that's where we put our Y values. We don't have a frequency list because we're not dealing with frequencies, but we will talk about that later on. And we're also going to gloss right over store reg EQ, store our regression equation in other words, because we don't care about that yet, but we will. And then we're going to press enter. And that's going to spit some variables back at us. We've got A and B, which we'll talk about down the road, R squared, which we're not too interested in. When you take the square root of that R squared value, you get R. And R is our regression coefficient, our correlation coefficient. R is the value that we're looking for here. So to 3 sig figs, our R value is going to be 0.946. So here it is. R equals 0.946. So we've quantified now the relationship between X and Y, the relationship between number of rooms and number of chairs. Let's describe in words then, let's qualify what that means. So if we have an R value of 0.946, we know that that is positive. It's a positive value. It doesn't have a negative in front of it. So we know for sure that the relationship is positive. What that means is that as X increases, Y also increases. And this is what I was hypothesizing to be true. As the number of rooms in your house goes up, the number of chairs that you have in your house will probably also go up. Now we need to talk about strength. So our R value here, we're looking at positive correlations. Our R value was 0.946. 0.946 is between 0.87 and 0.95. It's so close to 0.95, but it's not quite there. So what we have here is a strong positive correlation. So it's positive and strong. And what that means is that there is, in fact, a relationship between the number of rooms and the number of chairs. It's not arbitrary. The more rooms you have, the more chairs you can expect to have in your home.